Hi math students, it's Mrs. Marcellus and special guest Einswine. Today's lesson is to divide decimals by whole numbers. Today's learning objective: the student will calculate the quotient of a decimal number divided by a whole number by applying standard algorithms. And if you remember, a standard algorithm is the standard process, so we'll be doing basic long division today. Our vocabulary words: quotient, the result of division; dividend, the number that is being divided, the starting value; divisor, the number the dividend is being divided by. What's that you say, Einswine? You always get confused trying to figure out which number goes inside the division bracket and which number is on the outside of the division bracket? Well, that's really important because if you have the problem set up backwards, you're going to get the wrong answer. So let's take a look. The dividend, or the starting value, gets divided by the divisor, and it equals the quotient. The dividend is the first number. The first number always goes inside the bracket. The divisor is the second number. The divisor is on the outside of the bracket, and the quotient will go on top. Or in other words, the first number divided by the second number equals the answer. The first number goes on the inside, the second on the outside. So you can kind of think like being the first person to go into the restroom, perhaps. First number is in the restroom, so the second number has to wait on the outside until the first number comes out. And of course then the answer goes on top. Did that clear things up, Einswine? Okay. Awesome. Then let's do some examples. In our first problem, we're going to divide 7.4 by 2. This means we have 7 4/10 of something, and we're going to divide it into two groups. The first number, 7.4, goes inside the division bracket. Then we're going to divide by 2, so the divisor goes on the outside. When dividing, you take one digit at a time. There should always be some response in the quotient for each digit that's in the dividend. First, we'll look at dividing 7 by 2. How many times does 2 go into 7? And that would be 3. So we write the 3 in the quotient. 3 times 2 is 6. Then we subtract that value. It is only then that you bring the next number down. So we're always going to bring a number down and then put a number in the quotient. Next, we're looking at how many times will 2 go into 14. 7 times 2 is 14. So we subtract and we have no remainder. When you have no remainder, you're almost done with the problem. The final thing to do is to put the decimal point in the answer. When dividing a decimal by a whole number, the decimal will go straight up in the answer. So our final answer is 3 7/10. You can always check your answer by multiplying the two numbers on the outside, 2 times 3.7, to make sure you get the number on the inside. Or in other words, you multiply the divisor times the quotient to see if you get the dividend. If we do that check, we do end up with 7.4, so we're correct. Let's go on to the next problem. I'll put the first number inside the bracket, 3 49/100, and we're dividing that by 4. First I check to see, will 4 go into 3? 4 does not go into 3. I always like to put a 0 there just as a placeholder to make sure that I have accounted for that digit. Then I move on to the next digit. I ignore the decimal and I just see how many times will 4 go into 34. 8 times 4 is 32, so that's close but does not go over. I'll subtract and have 2. Next thing I want to do is bring a digit down. You always bring a digit down before you put an answer in the quotient. 7 times 4 is 28. So I subtract and I have 1 left over. When you have a decimal number, you cannot have a remainder. I can't just put that the remainder is 1 because it's not one whole. It is some place value. It would be tenth or hundredth or thousandth, and we're not quite sure what that is. You must either continue dividing until the answer terminates. You have a remainder of 0. The answer repeats, and we'll be working with repeating decimals later in the year, or you've been given instructions to round to a certain place value. In order to continue with the problem, I will need to annex some zeros. I'll annex a 0 next to the 9. Then I will bring the 0 down, and I'll continue with the division. 4 goes into 10 2 times. 2 times 4 is 8, so I will subtract the 8, and I have a remainder of 2. Well, darn, I'm not done yet, so I need to add yet another 0, and I bring that 0 down. I can see that 4 goes into 20 5 times. 5 times 4 is 20. I subtract, and I now have a remainder of 0, so I know that I'm done. The final thing I need to do is put the decimal point in the answer. The decimal point goes directly above its location in the problem. My final answer, 0.8725. In our next problem, we'll divide 22 and 99 hundredths by 11. Start by putting the dividend, the first number, in the division bracket, and the divisor, 11, the second number, on the outside. When dividing by a double-digit number, we still consider one digit at a time. So first we'll decide, can 11 go into 2? It can't, and I like to put a 0 there as a placeholder. Then I'll include the next digit and check to see if 11 goes into 22. 2 times 11 is 22. I will subtract 22 and then continue by bringing down the next digit. This is a place where students often make mistakes. They'll look to see whether or not 11 goes into 9 and see that it doesn't, and go ahead and bring down the next digit. But every time you bring a digit down, you must put something in the quotient. 11 won't go into 9, so 11 goes into 9 0 times. 0 times 11 is 0. And it's only at this point that you can bring down the next digit. 9 times 11 is 99. After you subtract, you have no remainder, so you know you're almost done with the problem. The final thing that you need to remember to do is put the decimal straight up in the answer. 22 and 99 hundredths divided by 11 is 2 and 9 hundredths. Now getting back to bringing down that 9, as you can see, each digit in the dividend has exactly one digit above it in the quotient. There is always a one-to-one correspondence. You would never have a double-digit number written above a number in the dividend. Each one is one-to-one. You have a single digit above a single digit, and they'll match up. This is where the graph paper comes in really handy, because it helps you avoid making those mistakes where you accidentally bring down a digit and don't put anything in the quotient. Let's move on to our final problem, a word problem. In this problem, Judy and 3 friends are taking a cruise. The total cost is $3,082.24. Judy saved $900. How much of her savings will Judy have left after she pays for her part of the cruise? This will be a multi-step problem. The first thing we need to determine is how much each person needs to pay for their part of the cruise. Since it's Judy and 3 friends, we'll need to divide the total cost by 4. The dividend is the total amount paid for the cruise, and the divisor is the number of people. First we see, will 4 go into 3? It won't, so as always I like to put a 0 there just as a placeholder. Then will 4 go into 30? And that would be 7 times. 7 times 4 is 28. So we subtract, and we have a remainder of 2. Bring down the next 8. 7 times 4 is 28. And after we subtract, we have 0. Remember to first bring down the next number, and this is where you have to be careful. 4 doesn't go into 2, but we can't just bring down the next 2 until we put something in the quotient. Since 4 goes into 2 0 times, we must write a 0 in the quotient. Then we are able to bring down the next 2. 5 times 4 is 20. We'll subtract the 20. We have a remainder of 2. Bring down the 4. 6 times 4 is 24. And then we have that remainder of 0. So we know that the trip will cost each person $770.56. Judy saved $900, and we want to know how much she'll have left after she pays for the cruise, which means we're going to find the difference or subtract. When subtracting, remember that you need to put the larger value on top. She started with $900, so we'll put 900 on top and we'll subtract $770.56 from it. Of course, we must line up the decimals, and in this case we'll need to annex a couple zeros in order to subtract. Now we need to borrow, so the 9 becomes an 8, and that will be 10, but that doesn't solve our problem, so we borrow again, and we'll borrow again, and borrow one last time. When we subtract, 10 minus 6 is 4, 9 minus 5 is 4, 9 minus 0 is 9, 9 minus 7 is 2, and 8 minus 7 is 1. That means that Judy will still have $129.44. Wow, Einstein, I think that a cruise sounds like tons of fun. What do you say we go research what it would cost for us to take a Caribbean cruise? Well, math students, this does conclude our lesson on dividing a decimal by a whole number, so we're going to wave goodbye for now.